Hello, my name is Kruthi and I'm a chemical engineering major at USC. I work with the Young Scientists Program for the Joint Educational Project housed within USC Dornsife, and I teach 3rd grade science at the Dr. Theodore T. Alexander Science Center School. Today I will be showing you guys how to do a science experiment called rainbow milk. For this experiment, you will need some food coloring. I have 4 colors here. I have red, blue, green, and yellow. And you will need a shallow bowl filled with some milk. I also have an additional bowl of almond milk just to demonstrate an additional concept about why this experiment works the way it does. And I have a toothpick for each bowl, 1 toothpick for each bowl, as well as some dish soap. You don't need too much. I just have about 10 drops in here, and that is all you need for this experiment. The first thing you want to do for this experiment is take 2 to 3 colors of food coloring and put about 2 to 3 drops in different areas of your milk bowls. So I'm going to do red and yellow for USC in the milk. Just dropping 2 or 3 drops in there. And you want them to be in different areas of the milk so that they're not mixing. So now I have my colors set up. On the left is the almond milk. This is the almond milk. And on the right is our regular milk. The next thing we're going to do is take our toothpick, dip it in a bit of dish soap, make sure it's well coated, and then dip it right between a couple spots of food coloring. Now isn't that cool? You can keep dipping it around and watching the food coloring go all over the place. You can start to swirl it, you can start to do other things. And this is why it's called rainbow milk. It makes all of these different colors, makes this swirl. Let's try it right here. Sometimes scientists call this the dancing colors. I just like calling it rainbow milk, but you can make a lot of cool things happen this way. So now I'm going to try, oh, I lost my toothpick. I'm going to try dipping it in the almond milk as well. So let's go over here. Make sure my toothpick is well coated again. Let's see this. And then we're going to dip it in here. Make sure it's in the right place. And now you'll notice that it wasn't as strong of a reaction. And we're going to talk about why that is in just a second. So we can see our colors have started to settle a bit. If I grab a little bit more dish soap and dip it into the milk, the colors will still repel from one another. They'll still go outward. Now, this is going to be a little bit different from the almond milk. If I cover it or put some more dish soap in, the reaction is not quite the same. We don't really see much happening here, right? All right, so now we have a bunch of different colors in our milk, and we have them all swirling around. And we also have noticed that the milk looks very different from the almond milk. So let's talk a little bit about what's going on. So our 3 components, milk, dish soap, and food dye, are all made of different things. Food dye, I will even show you the ingredient label, is pretty much just made of water and different colors inside of it. Dish soap is made of a part that loves water. It's called hydrophilic. Hydro means water and philic means loving. And the other part of dish soap is hydrophobic. That means it's afraid of water. Milk contains a lot of fat, and I used whole milk, so it has a lot of fat. And it contains some water in it as well. So milk is pretty much a mixture of fat and water. Water, of course, is hydrophilic because it loves water, it loves itself, and fat hates water. So when we put the dish soap into the milk, some of the soap binds to the fat. The soap molecules will bind onto the fat molecules, and the food coloring molecules will just have to find their way around that. This bonding is what causes the colors to kind of explode the way we saw them. So just to demonstrate that again, if there are any unattached fat molecules right now, we will see it happen again. And it's definitely happening again. You can keep this experiment going for a good amount of time too. This is just soap binding with fat. and repeatedly sending the water molecules or the food dye out. So these colors just keep changing a lot. You can keep it going until the water turns pretty much brown, but it looks like we have a way to go before that happens. The reason that this doesn't work as well with almond milk is because almond milk is made up mostly of water. It's called milk because people use it as a replacement to drink dairy milk. I, for example, can't drink real milk, so I use almond milk. That's why I have it in this video. But if I put the toothpick in, you'll still see that the colors will kind of move away from each other, but they won't do the same explosion that they did in the milk.